We're recording a study session on Monday, 18th. This is sort of the beginning of week 3, but not really till Wednesday because of the holiday. Someone has requested doing, someone has recorded problem 3 from homework 2A. As a reminder, homeworks are due Mondays at midnight. So this is not due yet. You still have time if you're watching this later today to get things done. Okay. So how much was borrowed at 120% annual simple interest for 2 weeks if the interest was $16.15? So we'll go back and find our finance formulas. So which formula to use, right? So here's that link about the different finance formulas. Which one do we want in this case?
So I originally went to, it's the percent, it's the P0RT. And I tried that one, but then I couldn't get it to jive with this problem.
Okay, I'm gonna grab the version I like.
Okay.
Because all of that P0 stuff tends to confuse people. It's important I have it on this page because that's what the textbook uses. If you are using the textbook link at the top, right? So hopefully you have been doing this. I've noticed some students, tangentially, not only aren't looking at the textbook for more example problems, but if you go each week into the things to do, then there's the activity. And the activity is sort of before the homework because you can practice things and have your own answer keys at the bottom. So if you're going right from lecture to the homework and skipping over the activity, then you're sort of asking for a little more confusion. But anyway, back to where we were. So yes, this is the simple interest formula. You did pick it out correctly. And like all of these, the hard part is setting it up. So I'm going to do my standard thing and use blue to get organized. The simple interest formula is the only one, remember, that it spits out only the interest, not the new total. So one thing that I'm doing when writing this is reminding myself that that's right, it doesn't say total amount like all the others do at the beginning. Okay, so the interest is $16.15. The principal, I don't know. That's the how much was borrowed. The annual rate is 120%. So I'm going to go right out of percent. And the years is 2 weeks. So 2 weeks will be 2 52nds of a year. If you want, I could take my fraction, the 2 over 52, and change it to a decimal. But then I'd have this long, ugly decimal to work with. So now I plug things in. Simple interest, 1615. Is my principal, which I don't know, times 1.2 times 2 divided by 52. I'm going to take all of this stuff and turn it just into one number. So 1.2 times 2 divided by 52. I'm getting 0.04615 and some other stuff, right? So now I have a format I like. Holler if you can't see the very bottom of my screen. I have something is y times something. So to get y by itself, I'm going to divide by that other thing. And I would just write it normally, like divide it underneath each thing, but I'm out of room. So I'll put off on the side, divide both sides by this thing. So what is that? 1615 divided by previous answer t gives me 349.92. Okay, question is now that it's on the board.
No, thank you.
Yeah, that makes sense. I think the 2 weeks out of the 52 weeks was like throwing me off, and I was like, I don't know what to do.
Mm-hmm. Yeah, because that's all it takes with these word problems. It's, you know, if you pick just the wrong divisors. I think I was going to, what did I do? Sorry for all the paper shuffling. I was doing like 1615 divided by 1.2. Anyway, I think I was making it more complex. So thanks. That was really helpful.
So David,
Oh, can we go over the short answer question on 2A?
Okay. Actually, before we do that, is everyone okay going from fraction to decimal here?
I am.
Fraction bars we can replace with decimals, so, or with not decimal, division. I'm saying the wrong thing because I'm tired. Going from fraction to division, right? Okay. Short answer. So if we took this simple interest formula, principal times rate times time, with the rate and the time both always being in years for simple interest, then the right way to do it would be to multiply the 100 and the 0.12 and the 5. We'd get 60, and if we wanted to find the total, we'd have to add back on the principal. So we'd take that 60, add back on the 100, and get an answer. Everyone okay on the correct part on the top? So it doesn't work to try and use the 1 plus trick. We were looking at for percent change. You can often use the 1 plus trick, but not in this formula. So what goes wrong? If I try and put a 1 plus r, where the r would be normally, that's the underlined yellow stuff on the bottom left, that would change the 0.12 to a 1.2. That's the yellow underlined stuff on the kind of bottom middle. And my answer gets way too huge. Instead of 160, I get 560. So why am I off by so much? Where does the extra 400 come from?
1 times like the 5 or 1.
Yeah, the 5 times 1 is making 5 copies of the principal.
Right. That makes sense.
So I don't want 5 copies of the principal. I just want 1 copy of the principal. So that's the, yeah, explain that in your own words somehow. As a reminder, especially if you came a little bit later, we have the jam boards from Thursday and Saturday are in the recordings after the to-do list for week 2. So if you are looking for other problems, check there too. Anything else from homework 2A?
Not with 2A.
I was wondering if we could work on the first couple problems from 2B.
Sure, let me change. Should we just go through 1, 2, and 3, and then maybe the answer version of 3?
Yeah, because I'm confused. I don't know what to do.
Should put a note up here. This is from homework 2A. Okay, and now we're going on to 2B. Okay. So she can spend $900 per month on mortgage payments. We're sort of imagining that she's walking into the bank wanting a loan and she has $900 in a suitcase. She says, how big a mortgage can I get? According to the table, then it's 5% in 30 years. So every time she spends $5.36, she gets $1,000 of loan. So far, so good.
Yeah.
So she walks up to the bank teller, opens her giant suitcase, hands them $5.36, and the teller gives her a thumbs up and says, congratulations, you qualify for $1,000 of loan. Good luck buying a house for $1,000. Then she reaches into her suitcase a second time, pulls out another $5.36, and now she's up to a $2,000 home loan. And she keeps doing this until she runs out of money in her suitcase. So what type of problem is that, or how many times does this number fit into that number?
Are we using the decreasing annuity? I don't know that word formula.
I'm just wondering, how many times does $5.36 fit into her $900?
I got the 168. Well, it was 160, like 7.9 something, and then I rounded.
Okay, how did you get that?
I just did 900 divided by 536.
Great. So how many times does something fit into 900? And that's a division problem.
Let me put this.
They're like a
In the
form.
calculator, I think it gave me, hold on. 100 divided by 536. Wait.
So looking at the
Well, the,
answers, the answer key is letting you round up to 160.
yeah, it gave me like 167.9, and then I like looked at the answer key and I saw it was 168, so I just rounded. But
I'm just gonna say this.
yeah, so I just did the
But
approximate.
that's
Yeah.
thousands of loan, right?
Mm. Right.
So is that really all it was?
Yep. That's why we use the table at the beginning, because it's so nice and easy.
I thought that was going to be so much more complex. I had no idea. I was like, what is this? I don't know how to do this.
Okay, if this wasn't obvious, it's because your old math teachers only taught you one way about division. So I'm going to do a little tangent now and talk about division. So if I have a bunch of cards, then I can deal out cards to model division. And this is the way most people are taught. It's what most elementary school teachers are familiar with, right? If I have 6 divided by 3 equals 2, imagine I have 6 cards in my hand. I have 3 people, so 3 of you pretend you're volunteers sitting in front of me at the table. And I would deal out my cards until they're done. And then the answer, the 2, would be how many cards each person has in front of them. So far, so good. So that's kind of the way people are taught to think about division. And the problem is that it doesn't really work for certain situations. If I want to divide by a fraction, I'm not quite sure how to do that. What's half of a friend sitting in front of me? Even if I took out my sword and chopped Lacey in half, I'm not sure how to deal out cards to each half of her separately or things like that. Lacey is frowning. I would not do that. Same thing if I'm dividing by 0. What's 6 divided by 0? I'm not quite sure what that means. How do I not deal out cards because there's nobody there, but I'm dealing out cards? Okay. So there's some conceptual blocks that happen if this is all you have. The other way is to think about making piles of a fixed size. I still have 6 cards in my hand, but now 3 is going to be a pile size. I'm not having any friends. I send my poker group home. I'm just saying I will do 6 divided by 3 by making piles of size 3. So I deal out 1 pile, 1, 2, 3. I deal out another pile, 4, 5, 6. I'm out of cards, so I stop. And my answer, the 2, come on, there we go. The 2 answer, that's now the number of piles. Things have switched from where they were before. It used to be the number of piles was my friends, this number, and the answer was how big the piles were, but we can switch that. Now I can say the divided by 3, the 3 is how big the piles are, and the other number becomes how many I make before I run out. And if I want to think about 1/2, now I can divide by 1/2. Imagine I have 6 playing cards and I'm in a very destructive mood, so I rip them all in half. How many piles of size 1/2 of a playing card can I make? It would be 12, because each playing card I can make 2 different piles out of. And 6 divided by 0, it actually isn't quite right to say it's infinity, but we can pretend it is close enough. So you can think about that. If I make piles of size 0, I can just keep going all day. I will never run out of my 6 cards making piles of 0. So the fact that that answer behaves like infinity makes sense. So that's what we just did. We're saying how many piles of size $5.36 fit into 900? And the answer was we got about 168 piles before we ran out of money in our suitcase.
Crazy.
Okay, if you were really bored, good for you. If that was like eye-opening, it's not your fault. It's just that whoever taught you math before didn't go into both ways to think about division. Okay, onward. So she gets a loan with a 25% down payment. So 25%, that's going to be 0.25. We already did one case of ripple up today. I'm not going to keep doing that. So I take my 168,000. Multiply that by 0.25. Why am I multiplying? Because I want 25% of a number, and of usually means multiply. And whatever that is. 42,000. So what is the 42,000 in real life? How should I label this?
The 42,000 is the down payment.
The down payment. So poor Brenda has to come up with 42,000 cash.
42 G's, that's tough. Well, for some.
Okay. What's the size of her actual mortgage?
So then we would take 168,000 and subtract the 42.
Right. Is it?
The
house
mortgage would
cost
be
is the 168, and anything she's not paying up front will be the loan.
126,000.
And you could label that loan or mortgage or however you want. And the actual monthly payment so we before used this table and got that she could have 168,000 of loan for a $900 monthly payment. But she's not going to spend all of this 900 on her actual paying off the loan to the bank. She has right now 126,000 of loan. So she's only paying to the bank 126 copies of that $5.36. So 675.36. So that's good. She has an extra about $224 each month under budget. What is she going to do with that extra $224? Probably deal with this down payment, right? She's borrowed it from a relative. She's taken it out of her retirement account, whatever it is, to scrounge up the 42,000. She has to somehow deal with that because she probably doesn't have it lying around in her savings account.
So when you got to the last step, I'm just curious how it became from 126,000 to being just 126.
Because the title of the table is every $5.36 you spend gives you per 1,000 of loan.
Okay, I get it now.
So she had 126,000 of loan. So she had 126 of those payments. Okay, we keep going. So the loan has a 2% fee. So we have lots of little bits here. Loan fee So that's going to be 0.02. And again, we're doing times because we're doing of. What's 2% of the loan? How much was the loan? 126. So 2,520. She also needs to prepay the first month. So that was 675.36. She also has 1,000 of other stuff. And of course, she has that 42,000 down payment. So all of those, we have to add them all up. That's an ugly line, straighter line. Okay. And we get whatever that is. So she needs quite a lot to get her house.
Hey, David, I keep getting $45,195.36. What am I doing wrong? So I've got 42. Oh, you know,
Did
it's
you
the
do-
$1,000 of miscellaneous that I'm missing. There we go. Duh. Thank you.
Okay. So that one was a little tricky because you had to use the table in two different ways. We used it with division to find out what size house she could afford. And then we used it with multiplication to say, once we knew what the loan amount actually was, then let's build up the payment based on the actual loan amount. Number one, we could do another way. So let me re-grab Brenda's problem. So we can use our fancy formulas instead of the table. So the principal, the big number, will be how big a thing she can afford. That's what we're solving for. So in this case, that's what the house size is. The withdraw, she's going to do 900 per month. Start our parentheses. So 1 minus 1 plus the rate per payout. 5% per year. So 5% per year. So I want to change that into a rate per payout. What's the monthly rate going to be?
is it going to be just 5% or is it going to be 5% of 900?
Neither of those. Okay,
Oh.
I'm confusing you on purpose by jumping into the formula too soon. So let me go back and see if this rings any bells. I need to delete this paragraph though, or I'm not going to have enough room on the page. So just remember this information, right? You have it in front of you on other page. So I need to do something because I have yearly amounts for the rate and the time, and I don't want that. Now this will physically on the paper look like things we've done a lot of times before. How do I get a per year rate and make it a per month rate?
Divide by 12.
And how do I, below that, take a number of years and change it into a number of months?
Multiply it by 12.
Okay. I'm going to open up the web page calculator. If you go to any of our things, there's a button at the top that says calculator. And then I'm going to punch this in where you can see me punching it in, because I think some of you are having calculator problems from the emails I'm getting. So 900 multiply, open parentheses, 1 minus, oops, it made me jump out of parentheses for some reason. So let's fix that. Okay, parentheses 1 minus, the 1 plus rate per payout is 1.0, nope, stop jumping out of parentheses. 1.0041, and then lots of sixes. Then I have an exponent, so exponent, negative 360. And then outside of parentheses, When I do division, it likes fraction bars for some reason. So it doesn't make me happy, but there we go. Divided by the 0.0041 lots of sixes. And we get as an answer the same thing we did, so much easier with the table. The formula is slightly more accurate because the table we're rounding in the middle of a problem. But for just how big a house can you afford, the table is close enough. If I didn't include all the sixes because I was looking at this number and rounding it too much and not putting all the sixes here, then it changes quite a bit. So put in lots of sixes when you have a repeating decimal. Lots of sixes. Okay, anyway. If you're having trouble getting this, then 167,653. Feel free to share your screen and try and make the calculator work yourself, if everything works except actually punching things in the calculator. Questions about any of that?
Admittedly, the negative exponent is a little unsettling, but I understand why it's there as I talk myself through it. I always get mixed up dealing with the negatives. I don't know why, but that's my only comment about it.
Okay.
Why is it negative?
Why is it negative? I could derive the formula, but you would think I'm just waving a magic wand at the end. There's something that looks very non-realistic in the steps to deriving it. Let's talk about negative exponents in a minute. Okay, what is a negative exponent? This doesn't make any sense. I can't multiply 3 by itself negative 2 times.
Don't you just, well, I don't know how to explain why it's negative and what a negative exponent is, but I think that you just put one, you just like flip it and then make it into a fraction of 1/3 to the negative or to the positive,
Yeah.
like second power. When you flip it, it turns it into a regular one. That's, yeah. So that's my explanation.
So that's what you've been taught to do. Why would that be an answer? Why does that make any sense? What people want is,
Yeah, I don't know why. I just know that like freshman year, they taught us that's what a negative exponent means.
move that down.
The main thing that comes to mind is that because it's a negative, you're moving from multiplication into division, which is why you would put it into a fraction form.
Mhm.
Am I on the right track?
Okay, so this second line with the blue and the green, I have 2 copies of 3 multiplied by each other. and I have 4 copies of 3 multiplied by each other. And that makes 6 copies of 3 multiplied by each other. So we get this rule that if I have one exponent and I multiply it by the same base with another exponent, then we're adding those exponents up. Can you see with my colors why I would add them? I have 2 and I have 4, and that makes 6 of them.
Yes.
If you think of 3 squared as 3 times 3 is 9, then you get stuck. If you think of 3 squared as just 3 times 3 without the equals 9, then this makes sense. 3 times 3 times 3 times 3 times 3 times 3. Well, of course, that's just 6 3s. So if your math history includes lots of problems like this that encourage you to get to a number answer, then it actually slows you down when thinking about playing with more than one exponent at a time. Okay, so let's use that rule then. If we have 3 squared, and now I have 3 to a negative 2, then that should be 3 to the 0, and that's also a problem. What's something to the 0?
1.
1. And that's just because we want exponents to have a pattern. If I have a pattern of 3 to the 1, 3 to the 2, 3 to the 3, every time I go down a step, I'm dividing by 3. So if I have 3 to the 0, then I want it to finish the pattern. And the same is true with any base. If I have 2 cubed, 2 squared, 2 to the first power, 2 to the 0, so anything to the 0 should be 1 because we like patterns. Everyone okay so far? So whatever this number is, it's the thing that when I multiply it by 3 times 3, I just get 1. So that has to be 1 over 3 times 3. So that's why we get our rule about negatives means make a denominator. And it follows the pattern too. If I have 3 to the negative 1, that's going to be another negative 3, or divided by 3. And if I have 3 to the negative 2, that's going to be another divided by 3. So we get a sense that the more the negative exponent gets big, the tinier our number is. And it will shrink faster and faster. So now back to the original question, why do we have a negative exponent here? Because the more months go by, then
The smaller the payment.
the smaller this part is going to be. So the closer the whole parentheses will be to 1. 1 minus a smaller and smaller amount gets closer to 1. And then 900 times 1 gets closer to 900. So this whole thing is going to approach your monthly payment as the months get bigger and bigger. And if we were to say, let's just imagine that all of this was gone in just a 1. What's 900 times 1? Divided by the 0.0041, lots of 6s. It's a number not too much bigger than this. In this case, it happens to turn out to be a little over 200,000, but who cares? The point is that if you had an infinite time of mortgage, if your months went on and on forever, you would wind up with a number that was your monthly payment divided by a tiny thing. And dividing by a tiny thing makes things bigger, but not infinitely huge. So we get kind of a big number. The smaller this is, then the less this part shrinks. So the farther this is from 1, because we're subtracting away more. So that means that you're effectively having a smaller monthly payment because we're multiplying it by something between 1/2 and 1. And that will shrink what your house size could be. So we see that in the amortization table. I'll get a big version. That as your years get smaller, you can afford less house. For the same size house, it costs you about twice as much for a 10-year loan as a 30-year loan. Okay, lots of words. Maybe that actually made sense, or maybe it didn't, but that's why we have a negative exponent.
Can we also go over number 4?
Number 4, sure.
Thank you for that clarification, by the way.
You're welcome. If you haven't ever been taught, say, division is making piles of the fixed size, or why negative exponents are the way they are, then you should go like scold your old math teacher and say, it would have been simpler if you taught it better. Anyway. Okay, so 4 is just like 1. I will grab the table. Here, table. There we go. The problem is that Zane is trying to trick us. Instead of saying 900 a month, he says you have to work a little bit. So his monthly budget we're doing 30% of 65,000. So again, of means multiply. So we'll take the 65,000 and multiply it by the 0.3. So 19,500, and that's per year. So how do we find out what he can spend per month?
You divide it by 12.
Yeah. So 1,625. His numbers are 15 years and 5%. So that gives $7.91. Everyone remember if we're dividing or multiplying in the next step.
Multiplying.
Yeah. Or dividing, actually, I think. I don't know.
Dividing.
Dividing. We take, he's arriving at the bank with $1,625 in a suitcase. And then he gives the teller $7.91 repeatedly. She very patiently sees how many times he could do that. And it gets to be about 205 times. And each time he does that, it's $1,000 of loan. So exactly the same as problem 1, but just this extra step at the top.
Thanks. I just got confused, but that explained it perfectly.
I like got a completely different answer because I skipped the so like I got to the 19,500, but then I forgot to divide that by 12, and so I ended up with like the 246,000 instead of 25.
Yep. If he could pay his entire annual housing budget each month, he would get a mansion. Let's look at the practice test while we're here. So we are in week 3. Welcome to week 3. Remember to use the Get Help forum on days like yesterday when I'm not at my computer much to do grading, and you could always ask each other for help. We have an activity this week. It might help you do more studying. There is a discussion forum for this week. Don't worry about it right now. Practice test, highlight here. Practice test, link again here. So let's look at these practice tests. When it says things will change, I'll talk about that in a moment. Almost nothing changes. So we have some problem-solving problems. For the finance, it's just what we've done. So monthly payment, we're not like Zane hiding it. We're just telling you right up front what the month was, just like Brenda was doing. So how large a home is affordable? What's the down payment amount? What's the fee? Then it's asking a slightly different thing. It's asking how much will she pay total over 15 years? So once we know what her monthly payment really is, we just have to multiply it by 15 years times 12 months per year. And then it asks how much of that is interest. Should we do this set so you'll have this done before you try practice tests?
Sure.
Sure.
Yeah, that seems really helpful.
Okay. Okay, so it starts out looking very familiar. 15 years, 5%. So 791 for this problem. And then we divide. Okay, it didn't ask for what the actual loan was, but we're going to need that. So I did the subtraction in green at the bottom, the actual home size. And then maybe I even want to label that home size just to be extra clear. Oops. So take the home size, subtract away the down payment, and you get how much is the actual loan. Then in the red, what her actual loan amount was 92.13 of thousands. And pretending the thousands comma is where my place value whole numbers start. So I take that number, and that's how many $7.91 she needs. She's under budget. Again, she budgeted $879, and that's good she's under budget because she has some free cash to deal with this down payment now. Payback grant, whatever it is.
Refrigerator.
Everyone okay with what's on the board so far? So now is where it gets a little different than the homework. How much will she actually pay over 15 years. So she'll take the 728.75. She writes a check once a month. So she has 12 months per year for 15 years. She writes a total of whatever 12 times 15 is 180 checks. Each one was 728.75. So 131,175 $175 total paid. So that's more than the loan. Her loan is only 92,130. So why does she pay more?
Because of the interest.
The interest. In fact, everything that is extra is interest. So if I take what she actually pays out of her checkbook and take away that loan amount, 92,130, then whatever that is has to be the interest, because if it's not the loan, it's interest. So 39,045.
David, I have a question.
Sure.
So say someone receives a windfall,
Mhm.
your family member passes away, they leave you some cash, and it's enough to purchase a house. But yet you don't want to completely, you don't want to spend all of that down because you want to have some money. However, the question is, would you save more in taxes if you, over the, say, 30 years or 15 years, whatever your mortgage would be, to just, let me see if I can rephrase this right. What would be the smarter thing to do? To just pay for the house outright because of the level of interest you may pay, and then deal with the tax repercussions, or to actually take on a mortgage and then reduce the windfall by that amount each month?
Oh, well, like all real math problems, the answer is it depends. And they can tell you what it depends on and for what types of households things would be. But
Well, and what tools would you use in order to figure that out? So would you use an amortization table for one, or how, like?
you're actually asking just like, what are the goals of saving for retirement and how do I fiddle with that? So before I go into that, is there more homework specific things that people want to do?
Maybe number 6 on 2B. That one really kind of tripped me up. I had to skip it.
6. It's a lot like 3. So make sure you're including, wherever it was, including the down payment, the fee, the first month, the miscellaneous, and you're just adding those up.
Could we do the quiz number 2, the second number 2 on our quiz this week?
Second one on the quiz. Sure, that was a one that was bizarrely tricky for people. Do.
And David, as far as my question is concerned, it's kind of a big one. And
Okay.
so we don't have to get into it. I just thought you would say, oh, yeah, why don't you go ahead and use these two tools? But it's a pretty loaded question.
Yeah, no, I'm happy to, and it's a good thing. I just want to, whoops, kind of make a second recording rather than confuse that with the homework recording. So I will do this and then we'll transition over, and anyone who doesn't really care about that kind of investing question is fine, they can go. Okay, so which of our formulas is this? Remember, we have that formula page.
P times I equals P times R times T.
Yeah. So just like we kind of got into hot water before with, remember on this slide, if we jumped right into the formula, it didn't work well. We really want to set everything up with our blue organization. So same thing. So I'm going to get the P times R times T. Go back to our current slide and not skip the blue stuff. Okay, tell me what all these things are.
The interest is self, isn't it? Is it $5?
Yep, they just tell us it's fine. A bunch of people tried solving for fives somehow, but no, they just gave it to us.
I did the same thing, sadly.
Okay, what's the principal?
The 120.
Mhm. What's the rate?
I don't know.
We don't know. That's what we solved for. And what's the years?
0.25.
Yeah, so 3 months. Equals quarter of a year. Everyone okay with my blue stuff?
Yep.
That's where the hard part always is. Okay, so I plug it in, 5 equals 120 times some rate I don't know times 0.25. I'm going to switch these because when I multiply things, it never matters what order I multiply them in. Remember earlier when we took everything to the right of y and squished it together? Where was that slide? This thing, we're doing that again. I want to get y by itself. So first I scooted y so it's next to the equal sign, and then I'm going to take everything else and smash it together. So what's a quarter of 120?
$30.
And I can divide both sides by what's stuck onto y. and I get about 16.7%. What my calculator actually tells me is 0.1666666, right? But I'm calling that 16.7%. Because I'm at a room where I would have written it in 2 lines. There were a lot of people that wrote something that resembled this. Here's just someone's, as they turned in. And I'm not sure where they got the 4.17 from. I think I do know that, but it's not obvious because that's not a number that's anywhere in there. You can't just sort of make up the percent. We're supposed to be solving for the percent. So the moral of the story is remember all the blue stuff, right? Get yourself organized before you use the formula. It's not that the formula is hard, it's that real life is complicated and they don't always tell you the things that directly plug in the formula. Okay, I'm going to stop the recording.